this is experimental manipulation. You make up a scenario, you do something to those two groups, in those two groups that differs, and that's exactly the thing that you're interested in. Your independent variable, the variable that's assumed to do something in your research. And then you measure the outcome in both groups, you measure the dependent variables, and then compare those two groups. Since this will come up a couple of times, sometimes we'll call these conditions, experimental groups. Conditions is very, very often used. This would be the stimulus, the manipulation, the thing that we want the groups to react to, basically. And what we then do, statistically more or less, is you compare other groups in the beginning. This is turned around now. Other groups in the beginning actually the same. Are they equivalent? Then this group gets something, this group doesn't get something. And you again compare. And ideally, if your hypothesis was true, if your expectation that this thing is doing something to the group, to the people, is true, then you should find a difference between these groups. It's again this magic thing about randomization that comes into play. Touched on in the class about sampling already. So randomization, again, every individual has the same chance to end up in either experimental condition in either one of the groups that we're looking at. And due to the law of large numbers, this is a very similar figure that we looked at. We should see that the more people you use here, the bigger the chances that every one of those groups shares the same characteristics as the initial population, the initial group of people that you started with, the 80 that you started with. And if you take 40 out of those 80 here and 40 out of 80 here, for a random procedure, you should be fairly certain that those characteristics in the two groups match the characteristics of the initial, which in this case would be the population you started. Now I'm always saying 40 because that's the number which is usually, I'll come to that. I'll leave that one. But of course, also here, the more people you have, the more certain you can be that the randomization works. If you've only got 4 people and divide those into 2 groups, chances are very high that those are very different groups. Again, with 40 and 20, you're starting to get somewhere. With 80 and 40 per group, that's what many experiments will be using. So that's the one thing, that's the randomization into the different groups, and then there's different types of comparisons we can do. To know that A causes B, we need to know that not A does not cause B, and that A does not cause not B. And I'll illustrate that in a picture in a second, which is probably easier. We also need to know that C or D do not cause B, and again, C or D we control by randomization, by making sure that C and D are distributed equally in both groups that we look at. The groups don't differ on C and D, so anything we measure afterwards cannot be attributable to C and D, but ideally only to B. We can do 2 types of comparisons, and I want to talk about that for a few minutes. What we usually do is, now let's turn around again, you see, experimental group, control group. We usually, in experiments, see whether randomization was successful, that's how we call it, whether these 2 groups differ or not. And ideally they shouldn't. If randomization was successful, they shouldn't differ on a number of variables that we want to look at. Then this group gets an event, this group doesn't, gets stimulus, and then we compare these 2 groups again. And then the characteristic that we're interested in should look differently here than this here. sometimes we would, and this initial comparison we usually do on a couple of socio-demographic variables, for instance. So you want to make sure your groups are equal: age, gender, education, religiosity, discrimination, and so on and so forth. Whatever you have, basically. So you measure these in a survey in the beginning anyway. So people get a number of questions here, then get the stimulus here, and get a number of questions here. Sometimes what we do is that we measure the outcome variable, whatever we're interested in. Also here, same question, identical question. Say, we'll have an example about migration attitudes. So, do you think it's a good idea that a lot of migrants come into the country? That's the dependent variable we want to look at. But we could also ask the same question here. And that would allow us to look at intra-individual change. So I would ask you, do you think it's a good idea that immigrants come? Then I show you a story about immigrant crime. And then I ask you again the same question, with the idea that you being exposed to the stimulus should be changing your attitude. And people in this group shouldn't actually, because they don't get that story. So again, there's two types of comparisons. There's the between group comparison and the within subject comparison. Most of the times you'll be reading about experiments in the social sciences, you would see between group comparisons. Sometimes people do that. So again, experimental group sees something, does something, control group fills in the questionnaire without getting anything. What is the problem? What could be a problem if I ask you, do you like immigrants coming into the country? Then show you a movie then, a film clip or a video clip then, and ask you again, do you like immigrants coming to the country? What would be the problem with that? Could be a problem with that.
The movie film?
No. It's two problems at least. Really temporary change. It's getting to that direction.
Are we not assuming that the movie can change?
No, that's. I want to come to something different. That's the thing you study, exactly, whether the movie matters. That's fine. So that's not the problem. The problem here is that we as humans have the tendency to behave consistent with prior behavior. So if you say here, I actually think it's a pretty good idea that immigrants come into the country, and I show you a 5-minute movie clip, you will not have forgotten here what you said here. So the chances that you give the same answer here, no matter what happened here, are quite large actually. Yeah? And that's a real problem, and that's why in many of the cases I advise people not to do these post-test designs, not to ask the same question here and here. Yeah, when we do this stuff on party choice, if you tell me that I'm expecting something to change your party sympathies, you know what you said here when I ask you what party do you prefer. And you will remember that and are likely, because you want to behave consistently with your prior behavior, you're likely to say the same thing here again. That's the one problem. The other problem is that, I'm asking you about immigrants here, and then I show you a video clip about immigrants. The fact that I already mentioned the word immigration here, or immigrants here, might already prompt certain considerations in your head, and might make you to look at this movie with different eyes than you would have without me asking about migration here. Which is a second type of problem with these post-test designs. So the pre-post-test design, asking people the same question before and after the stimulus. The advantage that we can assess intra-individual change due to stimulus exposure, which is nice. It tends to be better evidence because I really can look at, did individual A change, individual B change, individual T, and so on and so forth. But disadvantage that people behave consistently and may remember the pre-test answer when providing the post-test answer, and also that people may be primed towards the stimulus when you ask them about the issue in the pre-test already. So, and these are real concerns. This is not just something you can argue away with. These are real concerns. So my advice to most of the students is don't do pre-post designs if you don't have a very good reason to do pre-post designs. If this individual change is very important to your research question, if you can disguise your pre-measurement very well, things like that. Another solution to this would be a design like this. We're basically only interested in comparing. We only have one stimulus here. It's 4 groups. We only have one stimulus. But for the first 2 groups, we do a pretest, and for the other 2 groups, we don't do a pretest. So the stimulus, the film is the same in these 2 groups. One would get a pretest, the other wouldn't get a pretest. That would actually allow us to see whether these concerns actually matter or not. Yeah, you can compare these 2 groups and would see whether the pretest did something. And then you have 2 control groups that don't get a movie, no stimulus, and also there you could imagine that a pretest would do something. This would be great if we could all do this in an ideal world, but unfortunately the world is not ideal, because doing this costs you twice as much money, twice as much time, and that's often not the resources we have to look at these little differences. So this is not something I would advise you to do. I would advise you to think about whether you really need a pre-test in your design or not. But this would be doubling the costs of everything, and it might not be worthwhile unless you have very good. Questions so far? It's a bit more technical, you see, right? I'm using more terms that might be less familiar. Dependent, independent variables and things like that. But in a way it's fairly simple, right? I mean, this basic experimental design is very simple. Group of people here, that could be anyone, right? Group of students, we could do an experiment now. 40 people, 45, maybe enough already. Group of people here, random assignment to 2 groups. One group's getting something, the other group's getting nothing, and compare the outcome between the 2 groups. Very simple. The great thing about experiments is, and we'll come back to the first slide really, is that experiments have a very high internal validity. We can be very sure that the stimulus, the thing that we're manipulating, is the cause of what we're measuring, what we're interested to look at. The outcome of the research is that the DV, the dependent variable, has been affected as a result of manipulation of the IV, the independent variable. The cause, the effect, the cause. Then it has internal validity. And that internal validity is very strong with experimental research. Great. Not so great. The findings can, in experimental research, often not be generalized to other settings, or much harder to generalize to other settings. So the external validity of experiments is usually very low. Findings can be, external validity would mean that findings can be generalized to other settings. This includes population validity, and so on and so forth. Logical validity. So, the internal validity of an experiment is high, because you can isolate the cause and effect, and you're very certain that the cause is the cause of the effect you're measuring. If randomization was successful, if your stimulus material was well done, and if your measurement was good. But we assume these things now. External validity in experiments is low, Because these experiments often happen, for instance, in an artificial lab situation. You invite people to come to a room in university. You pay them for doing so. You're setting them in front of a computer. You're asking them to fill in questionnaires. That's all very unnatural. That's all stuff we normally don't do. And then they should be watching a movie clip and should pretend that they're watching the movie clip as if they would be watching it at home. Or on your mobile in the bus, or whatever you want to do. You force people also to attend to certain stimuli. Again, we had the horror movie stuff, right? You know, you force people to watch a horror movie that otherwise never would turn on a horror movie. And these experiments are usually done with very small numbers of participants. So we're not talking about representative samples or big samples, but again, since we know that roughly 40 people per group are enough for many of the things we're doing, you know, that's what you try to get, but not more than that. So many experiments would be looking at total groups of 100, 200, 300 people max. And we're relying a lot on convenience samples. These are not randomly selected people at the beginning, but again, students that are around and get credit for what they're doing. People on the street that you ask to quickly participate in something. Crowd workers on MTurk that you pay for doing your experiment. And also that makes the external validity quite low. There's a I forget who it was. There was one article a couple of years ago that was going on and on about the fact that about 80% that we know about psychology, experimental psychology, comes from US white college students. So all psychological knowledge that we have is basically, we know that it might be valid for white US college students, but whether it's valid in other contexts, age bracket and so on and so forth, you know, we don't really know. In experimental research, there is always a trade-off between this and this. You want high internal validity, that's great, but you do that at the cost often of low external validity. Yeah? The more tightly study is controlled, the less likely to generalize populations of research settings. There's some ways to move around that. I'm, in the interest of time, actually thinking this. Maybe one thing I'd like you to know is when you yourself are doing an experiment, if you ask people to come to the lab, it's very important to be the same person, no matter whether you lead the participants to condition A, B, or C. You know, we did an experiment on humor in news or in current affairs coverage. And I was a bit concerned that the student, you know, and people would be laughing when they would see a certain movie clip in the experiment. And I was a bit concerned that the student we had to conduct the experiment would behave differently when getting the people in that he would know that would have a lot of fun in the experiment. You know, he might be smiling a bit more, talking differently than when you get the people in that he knows would be watching a very boring clip. So that's just quick advice from this slide. Be as in the survey yesterday, be neutral as an experimenter for whatever you do. So that's the very basics for experimental designs. If you've got that, you know, if you've got, was it anything unclear? Because if you've got that, then I think the rest should be quite okay to get. We're moving into what we very often see in experimental designs as well, into factorial designs. In factorial designs, you might be interested in more than one aspect of your stimulus material, which is often the case. These theoretical assumptions about, you know, when you show a clip about violent immigrants, you might have several things that might play a role here. Their skin color, the type of violence, things like that. And you're interested in the combined effects of that, not just the independent ones. So, is the movie about a violent black person that commits physical violence? Is that working differently from a movie about from a European perspective, violent Eastern European that steals something somewhere? There's different aspects to what you might be interested in, right? Again, attitudes towards migrants, country of origin and education, for instance, classic example. So if you ask someone, do you think it's a good idea that many migrants come to the country? And we've seen that yesterday also in the slides. You could speculate that the country of origin does play a role. So the Austrians might be much more acceptable towards the Germans than they are towards the Bulgarians. Poor country, rich country. And they might be much more accepting of high-educated immigrants than of low-educated immigrants, right? So you have an interest in your experimental study to look at these two factors, but also the combination of these two factors. So is the high-skilled, high-educated immigrant from Bulgaria more wanted than the low-skilled immigrant from Bulgaria, and how does that relate to the high and low-skilled Germans? Fisher came up. Fisher, that's the. If you know anything about the statistics, you might have heard about Fisher's stat. That's the Fisher guidance. Fisher in 1960 tried to formulate these factorial designs for experiments that more structurally. We usually have knowledge that any one factor will exert effects independently of all others that can be varied, or that its effects are particularly simply related to variations in these other factors. If the investigator confines his attention to any single factor, I don't have much time. I'm skipping over this, but I think the point is clear. So you're looking at different factors in one experiment, and the big advantage, you can look at interactions, at combinations of these factors, which are often also more externally valid stimuli. And if you do that in a factorial design, you get greater efficiency, greater comprehensiveness, and a wide deductive basis. And in a second, it's clear what that means. So the factor in the factorial design notifies the experimental manipulations of a given concept, and the levels the number of manipulations. So the factor in the example we just saw is the country of origin, factor 1, and education, factor 2. So we're dealing with two factors here. And each of these factors has, in this case, two levels. It could come from a poor or a rich country, two levels for factor 1, or it could come from a high versus low education. It could have a high or low education. That's the two levels for factor 2. Factors, the concept that we're interested in, levels, the number of dimensions that the concept is broken up into. And in the factorial design, now it would be nice to have something to draw. You basically bring these two together, like in a crosstab. So you have a low high income person and a poor rich country person. So you have combinations of poor country high education, poor country low education, rich country high education, rich country low education. Yeah? That means 4 experimental groups in this case. One factor has 2 levels, the other factor has 2 levels. These are the combinations. You get a maximum of 4 different types of combinations in this case. So that means you're having 4 experimental groups you need to look at. One group, let's keep with it, we'll see an article about a migrant from Bulgaria that's high educated. The other group, an article about a migrant from Bulgaria that's low educated, and so on and so forth. Yeah? Now you could say, I'm also interested in gender. People might be, it's hypothetical, it's just an example. People might be more willing to accept females than males, for instance. Yeah? Which I think would be the case currently, especially when it comes to Muslim immigrants. You read a lot about the evil male Muslim immigrants in Europe and the not so good opinion. Not my opinion, but that's part of the discourse of what's going on. That gives you another factor, the third factor. The third factor would be gender now. And you can look at whether a Bulgarian high-educated female would be more accepted than a, where is it, Bulgarian high-educated male. Yeah? You've got three factors now: education, country of origin, gender. But now watch what happens. You already have 8 experimental groups. So it's really nice, this factorial design, to combine things. But be aware of the fact that as soon as you start combining more than 2 things, you're very quickly running into very large numbers of groups you need to look at. So this is 8 groups, of course. That's the 8 possible combinations. When you have 8 groups times 40 people at least, you're looking at 320 people you need already, versus only 160 people here. It just doubles the amount of effort. Every factor, every 2-dimensional factor, 2-level factor, doubles the amount of groups you'll need. Imagine now that we wouldn't only be interested in high and low education, but also in middle education. You would add another layer to this. Just in terms of how this is sometimes, this is small again, sorry, sometimes being written down. So this would be 3 to the, how do you say that in English again? 3 to the power of 2, right? Yeah, 3 to the power of 2 factorial design, or the 3 by 3 design. You've got 2 factors, country of origin and education, and each of that would have 3 levels in this case. So poor, medium, rich countries, low, medium, high education. That's a 3 to the power of 2. No, this is not. Yeah, that's true. Yeah, same goes here. You've got 3 factors, each 2 levels. 2 by 2 by 2 is 8. That's the case we just looked at, right? And this would be 9 groups. You could have 2 factors, then 4 factors with 2 levels and 1 with 3 levels. That would be the case for this one. And you quickly ended up at 48 experimental groups, which is, in a lab setting, when you need real people coming to a place, pretty much impossible. So most of the designs that you would look at when you look at a lab setting, i.e. getting real people to a real location to do something, you would probably look at a maximum of a 2 by 2 by 2. Already 9 groups is getting tricky. You'd invest a lot of effort. So the full factorial design does take into account all combinations of all levels of all factors. Yeah, that's what we just looked at. So every possible combination of these factors is being taken into account. Now you could sometimes say, some of these combinations are not relevant to my research. Some might not have external validity. This is a very stupid example now, but suppose there are no female migrants from Bulgaria because only males are coming. Why would you then look at it? And then you end up in a partial factorial design. So you would purposely delete certain combinations. If you do so, you need to have a good reason why you do so. We did an experiment on the layout of online news sites, and we had the existence of hyperlinks, the existence of pictures, and of, what was it again? Oh, I can't remember. But there were some weird combinations of things that just didn't exist. There wasn't a website that would have pictures and multimedia, but no hyperlinks. No way to interact with anything. So we just left that out because there wasn't any external validity to what we were doing. Now we need to quickly talk about the notion of a control group.